Whenever a cell is connected to the bulb, electrons start flowing. The electrons start from higher potential and flow through the external circuit and come back to the cell again. When the electrons start from one end of the cell and come back to the same position again, we call the circuit as a closed circuit. Electrons are flowing through the circuit. They carry the energy with them and they deliver this energy to the device or equipment through which they are flowing. Example, if the electrons are flowing through the filament of the bulb, then their energy is transferred to the bulb. The transfer of energy depends upon two factors. One is the voltage and second one is current. Thus, the electrical power and electrical energy depends upon two factors. One is the voltage, another is the current. Also, more the power, more the energy, less the power, less the energy. So energy depends upon power, but also depend upon time for which the current is flowing through the circuit. Because more the current flowing, more the energy carried. Because more the energy implies more the electrons are flowing through the circuit. Thus, electrical energy depends upon the power as well as the time for which the electrical current is flowing through the circuit. Before moving ahead, let us understand what is voltage. Voltage is a kind of pushing power. It is like a pressure. It is like a force. It pushes lazy electrons from one point to another point. More the voltage, more the force, and more the electrons will flow through the given loop of electrical circuit. Here, I use the word lazy electrons. So why I call the electron as a lazy electrons? Because electrons cannot move on their own. If we just cut off the wire or just cut off the electrical supply stops immediately because electrons cannot move on their own. They require certain pushing power. They require to be connected to a voltage source. Then only electron can move from one point to another point. Here in this animation, one man is pushing the car. So the car is moving ahead. On other hand, the source of voltage is a battery and the value of voltage equals to 10 volts. Now suppose we increase the number of men pushing the car or we increase the value of the voltage. What happens? Let us see. Now, two men are pushing the car and the battery voltage equals to 20 volts. In earlier case, the battery was 10 volts, so only one electron was flowing. Now when we increase the voltage twice, that is from 10 volts to 20 volts, what do we observe? We observe the two things. Number of electron flowing has increased and the speed of electron also increased. It implies when we increase the voltage, more energy will be delivered to the circuit element. As the voltage increases, electron flow faster and more current flows through the circuit, provided the resistance of the circuit remains constant. Now, second thing I would like to tell you, if electron is flowing for the longer time, then they deliver more energy to the equipment. If the electron is moving for shorter time, less energy is delivered to the equipment. Thus, electrical power is decided by value of voltage and value of current, whereas the electrical energy depends upon power and time. Here, The main job of the electric cell is to push electrons. And while pushing the electrons, the cell has to perform work. So power of the cell is nothing but the rate at which work is done. Now let us derive the expression for power of a cell. Rate of work done is called power. So power equals to work done upon time. So when the current is flowing through the circuit, there are the two directions of current. One is a conventional direction of current and another is a electronic current. So there are the two types of direction. I will not go into that factor. I just want to tell you that current is flowing. So the current is flowing through the circuit equals to I. When the current is flowing, current flowing nothing but flow of electrons. So when the electrons are flowing, work is done. Therefore, power equals to electrical work done. Work done by the source of energy, that is a battery. Battery is performing the work. Therefore, electrons are moving from one point to another point. Flow of electron nothing but called as a current. So electrical work done is given by voltage multiplied by I into T divided by T. Therefore, power equals to VIT upon T, and T get cancelled. Therefore, power equals to voltage multiplied by current. Here, the unit of work done is joule and unit of time is second. Therefore, this is in the seconds. Therefore, power is measured in joules per second, and 1 joule per second is equals to 1 watt. From above discussion, we can define now electric power as follows. The power in a DC circuit is equal to the product of voltage and current. It is rate of transfer of energy with respect to time. Electric power equals to voltage multiplied by current. That is, electric power equals to product of voltage and current. Unit of electric power is watt. Electrical energy is defined as the product of electric power and time. Electric energy equals to electrical power multiplied by time of flow of current. Since electrical energy depends upon power and time, unit of power is watt and unit of time is hour. Therefore, unit of electrical energy is watt hour.